How you doing? Will Beatty with Centerforce Clutches. Welcome to the 2012 SEMA Show. Right here we have Josh Barnett's GT500. Josh will be driving this car in the Optima's Ultimate Street Car Invitational this year. He is the MMA fighter, and in this car, I wanted to show you a little bit what we put into this car and what we did to get it ready for that show. Okay, here it is. This is the clutch that we have in Josh's car. This is our twin disc diad clutch. Let me pull it apart here real quick and kind of show you how it works. Floater, disc. What we do is we run a low inertia one-piece steel flywheel. As you can see, the areas that we've taken out of the flywheel here, ARP studs, and we also supply ARP crank bolts. The drive disc, this is the sprung hub disc. This is all chromoly components here. These are our dual puck facings, steel back linings we manufacture in-house. We chose to go with a positive drive floater system. This floater system we know is the strongest one available, so this is what we wanted to run and make sure we put the very best in your car. One of the drawbacks to this design is a rattle that you get, what we call floater rattle. What we designed is this pin system here. You can see it's every 120 degrees. There's a slot in the flywheel. These pins locate into that slot in the flywheel. What it does, it locks that floater down, and now it can't rattle. Then we went with the second disc driven here. As you can see, input shaft never touches the second disc. So all the spring dampening is done with the one primary disc. Pressure plate goes on top. You have 1,324 foot-pound of torque holding capacity with this clutch right here. That is what is in Josh Barnett's car. Okay, let me show you our featured product here at this show. This is a twin disc for the Dodge Cummins diesel. We worked on this for quite a while, and I think we have it set. This is the twin disc. Again, our friction material. What's different about this twin disc is that this is a vented floater. This is something we went through. You can see the vents in here much like a brake rotor to help with the cooling. Second disc, flywheel, studs, just like the normal diad, but only two sprung discs versus that one. Again, floater fits in here. This clutch here is rated to hold 1,800 foot-pounds of torque, coupled with this pressure plate ball bearing design, and I'll show you a little bit about what the ball bearing design does right here. All right, what we have here is, I wanted to show you our ball bearing design. What we do internally to achieve our clamp load is completely different than anyone else. This is all broken up into thirds to kind of give you an idea what this is. This is what a standard clutch would look like. There's two ways to achieve clamp load. One is to move that machine that peak in, or change the diaphragm. The problem with machining that peak in is as you machine it in, you actually decrease the thickness of this pressure plate. What that equates to is less life in the clutch. So what we do is we actually take a ball bearing and put it in there. So we'll take that whole peak off of there, and now we can move it in as far as we want to achieve that mechanical advantage, that fulcrum point. Get us the clamp load we want. Same time, we can tailor the thickness that we want to make sure that that pressure plate goes back into all the OE specs. The other upgrade would be to go to our light metal series. This is how we achieve our clamp load. I'm Will Beatty with Centerforce Clutches. It's a 2012 SEMA Show. Thank you for watching. For more information, please visit centerforce.com.